So in order to graph functions with translations, it's going to be very similar to graphing a parent function. We just want to make an XY table. We want some negatives and some positive values. So here, if you look at this, if you plug in -2 and we take the square root of that, that is going to be no solution. So that won't have an output. And -1 here will not have an output. But 0 will. 0, square root of 0 is 0, minus 4 would be -4. The square root of 1 would be 1, minus 4 would be -3. The square root of 2 minus 4 is going to be a decimal answer, so that's not really a good input. 3 will not be a good input for, but we know the next perfect square will be 4. So we have square root of 4 is 2, minus 4 would be -2. And then if we put in 9, we know that's also going to give us a perfect square. Square root of 9 is 3, minus 4 would be -1. So we can sketch that graph. You get 0, -4. Oops, that's not right. Sorry, 0 over 4 down. There we go, not that one. 1 over 3 down. 4 over 2 down, and 9 over 1 down. So again, we get that sideways parabola shape, but now, since we have this, it has shifted down 4, which we should have been able to predict just from our equation, since that's the outside or the k value. We know it shifts down 4. Now for number 2, when we plug in -2, -1, 0, 1, 2, we're going to get a little bit different answers. This is not the same as this, which hopefully you can see, because this, the radical x is underneath the radical. Here, this is not underneath, or this is underneath the radical, this is not. So it will be a different graph. So we need to still try our negatives just to make sure that they're not going to work. If we plug in -2, we get -2 minus 4 is -6, so that's not going to work. -1 minus 4 is -5. There is no square root of -5. There's no square root of 0 minus 4, -4. There's no square root of -3, and there's no square root of -2. So our issue here is this is actually getting shifted to the right 4. So our graph isn't even going to start till we get over to 4. So since we know it's going to start at right 4, we should actually start our graph at 4 to the right. If we started at 4, we get 4 minus 4 is 0. Square root of 0 is 0. So now we have a point here that does work. And if we continue to go to the left, 3, 2, 1, we know those aren't going to work. We're going to continue to go to the right. So 5 minus 4 is 1. Square root of 1 is 1. 6 minus 4 is 2. Square root of 2 is a decimal, so that's not going to be very easy to graph. 7 is going to be square root of 3. That's not very easy to graph. 8 minus 4 will be 4. Square root of that is 2. So that's a good point. Since we started at 4, our pattern is usually 0, 1, 2 and 3 don't work. 4 does work. And then we know 9 also works. So here, if we started at 4, we're going to adjust that by 4. So 9 plus 4 would be 13. Would actually be a perfect square, because we get 13 minus 4 is 9. Square root that, and we get 3. You can use any values you want, but this system right here will just help you get more perfect squares, or you can just keep going until you get a perfect square. So we can graph this 4 over 0 up, 5 over 1 up, 8 over 2 up, 13 over 3 up. And again, we get that nice sideways parabola, so we know we've done it right. And I just want to give you one more example, or at least start it. What happens if something goes left 4? Well, that would be y equals radical x plus 4. And there we would start at the point -4. So when you do your table, you actually want to start at -4, so that you make sure you get all your values. If you start at 0, or if you start at other values, you're only going to get part of this graph. Your graph will look like it shifted up and started here. So you have to make sure you test a big range of numbers to make sure you know you're getting your whole graph in the picture. If you, on your test or quiz, just graph this starting at 0, that's not going to be the correct graph. So you always have to look at the translations to see where you should start your graph. If we know that it's just a radical x here with no shift left or right, then we can always start at 0 because we know anything above that is going to be no real solution. But as we start to get shifts in here, we need to start thinking about where we want our tables to start.